Okay, find the rate of change of the area of triangle ABC as theta changes. So what is the rate of change of A, the area, with respect to theta when theta is 60? So I'm looking for the derivative really at a single point when theta is 60 degrees. Okay, so I need to somehow find the area of this triangle, and my function area will be a function of theta. Okay, because I need to find it with respect to theta, the rate of change of the area with respect to theta. So let's let A be equal to the area, and so we're really looking for dA d theta, which means I need to find A of theta. What function can I build? I need to build a function or build a model that relates the variable A, which is this area, and this function. I can see right away I have two sides and I have an included angle, so I know from trigonometry that the area of any general triangle, as long as I have two sides and an included angle, SAS, okay, as long as I have this situation, I can find the area of the triangle using this formula. A equals half AB sine C. Okay, AB with an included angle, right? So now I can just plug in my numbers and create my model, create my function, area as a function of theta. So A of theta is half A, which is 12. Okay, it doesn't really matter in this case, okay? Any of the sides doesn't matter. 12 times 10 times sine of theta. Okay, I simplify that and I get 60 sine theta, and now I take the derivative. Okay, so now this is going to be actually in what units? This will be in centimeters squared. Okay, area as a function, A prime of theta will then be 60 cosine theta, right? Because this stays the same. The derivative of sine is cosine, so that just becomes cosine. And my units now become centimeters squared per radian. Okay, now this is kind of an interesting thing, because my answer was given in degrees, or my question said theta is going to be in 60 degrees. So why did I suddenly decide to change to radians? Why did I suddenly decide to change my units to radians? Well, if you think about the derivative of sine, okay, we learned that the derivative of sine is cosine of theta on one condition. What's the condition? The condition is that theta must be in radians. That formula only works if theta is in radians, okay? So anytime you take the derivative of a trig function, you have to change your theta to be in radians, or else it won't work. Okay, so that is very, very important. Okay, it's very confusing for some people, and they don't understand why you suddenly had to change from degrees to radians. Right, so 60 degrees is pi over 3, right? And what is then a prime of pi over 3? I'm looking for the change in my area, the rate of change in my area, okay, when theta is 60 degrees, or pi over 3. Okay, so I end up with 60 times cosine pi over 3. What's the cosine of pi over 3? Just for those of you who can't remember from your unit circle, pi over 3 is 60 degrees, so my triangle would look like this. Okay, I would have 1/2 root 3 over 2 and 1. The x value is my cosine, so that's 1/2. 60 times 1/2 is 30, and my units are then in centimeters squared per radian. Okay, so please remember this part. This is probably the trickiest part here. Okay, recall that this rule. Okay, theta must be in radians. All right.